In chapters 4, 5, and 6, we're going to continue to talk about probability, but we're going to specifically focus in on certain situations and specific types of experiments where we'll be able to see that probabilities will begin to kind of take on certain sorts of patterns. If we're able to find out what these patterns are, we might be able to exploit them to make the calculation of certain probabilities much, much easier. To get a sense of what we mean by this, we'll take a look here at the start of the types of scenarios and experiments that we're going to be interested in working with. So we have these different definitions that are going to be listed up here, and this first one is the most important. We're going to define here what we call a random variable. Now this is a very loose definition. There's actually a lot more complexity behind the idea of what a random variable is, but this will actually get us at least roughly started. A random variable is a numerical measure of the outcome of a probability experiment. So a random variable, it's something that could take on a numerical value that's the result of an experiment. So its value is ultimately going to be determined by chance. Random variables are typically denoted using capital letters such as X or A or B, but we use capital letters to stand for them. Now by itself, that definition doesn't really offer much. It might even be confusing. You might still have no idea what we really mean by that. Well, I would say consider some of just the following experiments that we've done so far in this semester. We've talked about things like rolling a die. When I roll a die and I think about some of the outcomes that can happen, if I think about the number that I might roll, that value that I could potentially roll could be considered a random value or a random variable. Its value will vary and it's totally determined by chance. I could also think about if I spin a spinner. We looked at something like that several sections back. If I spin a spinner and I ask how many times is it going to land on blue in 5 spins? Well, I could still say, well, I know what my answers are going to be. I either get like 0 blues, 1 blue, 2, 3, 4, or 5. And those are all determined by the random chance spin of the spinner. So these are the types of scenarios where we introduce this idea of a random variable. And now random variables are actually going to come in kind of two different versions or styles. We'll have random variables that are considered discrete. That is, the variable can only take on certain values. And therefore we can imagine that in some way the variable can be counted, or I can imagine counting up numbers of possibilities using my fingers or tally marks. And then we're also going to have what we call continuous random variables, which could really be any value. That is, the value of the variable could be any number within a given interval of values, and therefore would have to be measured. Now, we'll take a look at how all of this works down in example 1. But before we get there, I want to quickly go ahead and just kind of draw out a really quick picture to help us kind of orient ourselves in terms of where we are so far. We've already talked about in this class that a variable is really just something I can think of as like a question that I'm interested in asking to items or people that I'm trying to study, so that way I can get back a specific piece of information. And we said before in previous sections that variables came in two different types. They came in the form of qualitative variables, so I could ask people like, what's your favorite color? Or they came in quantitative form. A quantitative form, so like I could ask people like, what's your age? Well, what we see is that random variables up above have to be numerical measures, which means they are automatically going to be on the quantitative side. And once I have a random variable, I can further break that down into the type of being discrete or continuous. And so this little diagram that we have here helps us to kind of orient where these different definitions come in. So every time we talk about a random variable, we're working on the quantitative side, but we also want to make sure that we can understand whether my variable is discrete and number of outcomes or possibilities I can imagine being counted, or continuous, where the value of the variable can take on any number in an interval. To see kind of how this works, let's take a look down here at example number 1, where we're going to try to determine if the following variable is discrete or continuous. So let's take a look here. The random variable x represents the number of A's earned in a section of statistics with, say, 15 students. Okay, so notice here that I'm representing my variable with the letter X. It stands for the number of people that will end up earning the A. Now, I don't know how many people that is. That's why it's going to be a variable. So I know that the values that X could possibly take on would be like 0. That's an option. Maybe nobody gets an A, right? Maybe 1, 2, 5 people could get an A. All 15 people could get an A. But if you think about those possibilities, notice that this would be an example of a discrete variable. And the reason that I'm able to make that conclusion so quickly is that I know that I could kind of count up the number of people that get A's just using my fingers, like we said up here. Or if there were more people, I'd use tally marks. Okay, take a look then at part B. The random variable W represents the weight of a bushel of apples at an apple orchard. Okay, so if I imagine that I have a bushel of apples, can I go ahead and say that the weight of that bushel, is that something I can count with my fingers? Like, can I like stare at the bushel of apples and hold up my fingers in front of me and go, that's about 1, 2, 3, 4 pounds? No, I can't really do that. This is something where I need a tool to help me measure it. And this is the idea of what a continuous random variable is. That weight could really be pretty much anything from 0 pounds upward. And that value then has to be measured, i.e. using like a scale, a tape measure, a stopwatch. So here, this would be something that, yeah, maybe I'm going to have to put this on a scale to figure out how much it weighs. And so this variable would be considered continuous. Okay, what about the part C? The random variable Y represents the number of cars that travel through an intersection in an hour. Is that something I could count with tally marks or my fingers? Or is it something I'd have to measure using some sort of a tool or device? That's pretty easy to see. Imagine that you're actually standing out at the intersection. If you had like a clipboard and a pen or something like that, yeah, you could easily just go ahead and say, let's make some tally marks and just count up how many cars pass through. It's going to be discrete. What about part D here? The random variable K represents the amount of time that a shopper spends in the grocery store. Well, again, if I think about how much time the shopper could spend in a grocery store, they could really spend any amount of time. Like if I thought about these as times on a number line, it could be any time from like, say, 0 seconds to, I guess, as long as I could ever want. So I could really have any value in here. And I'm definitely not going to count how long someone's been in the store by using my fingers or tally marks. I would use something like a stopwatch or a timer on my phone or something. So this variable here would be considered, again, continuous. So understanding the difference between these discrete and continuous variables is very important. And here in Chapter 4, what we're going to be focusing on is discrete random variables. In fact, we're going to see that there are several different kinds of discrete random variables, all which exhibit different kinds of patterns. And again, if I can understand the patterns in the probabilities of these different variables, then I might be able to quickly calculate their probabilities. And we'll see how to do some things like that in the next video.